So today we're going to title our page One-Dimensional Kinematics 3. So one-dimensional kinematics 3, speed versus velocity. Speed versus velocity. So we have already said that speed is a scalar measurement, so it just has magnitude, whereas velocity is a vector measurement. So that means that we need a direction with velocity. Other than that, we're going to do a lot of the same calculations. We will be only a couple of times held up by the differences between distance and displacement. So if speed equals distance divided by time, we know that the unit of distance is going to be meters most of the time for us, and seconds most of the time for us. Okay, so a measurement of length and a measurement of time, whereas velocity is displacement because of the direction, but also that vector quantity. So displacement over time. The unit of displacement is also meters most of the time. The unit of time is seconds for our class. Now you guys know a lot of other units for speed. Okay, what is the unit of speed that you are probably the most familiar with? Miles per hour, absolutely. So we have miles per hour. We have kilometers per hour. We could do, in this class for our lab, we will probably measure in centimeters per second, because a meter is pretty long for what we're measuring. You could have any unit of length over any unit of time. Okay, we'll kind of see that in a little bit when we discuss these example problems. But I kind of want to look at these equations. These equations are 3-part formulas. So we can use our triangle for the 3-part formula. That helped some of you. Some of you thought that was a helpful tool. So we just want to be really careful that we realize what we're doing with this one. In this case, speed equals distance divided by time. So we're not going to be putting speed on the top. We're going to put distance here, speed, and time. Okay? So when we look at that, we know that if we need to find distance, we're going to point at distance and we're going to multiply speed times time. If we need speed, like the original formula shows, speed equals distance divided by time. If we need time, we're going to point at time, and we know that it's distance divided by speed. Okay, so being able to use that triangle will be super helpful for some of you. Some of you guys just want the formula. You just want to know exactly what it is. So we can go ahead and write those out. Speed equals distance divided by time. Speed equals distance divided by time. Distance equals speed times time. Okay, what does time equal? Distance divided by speed. Okay, distance divided by speed. So whether you use the triangle or whether you use the formula or whether you use algebra to just figure it out once you've got there, this is what we're going to need to do today. So if we go into the lesson and we kind of look at those examples, here's the first example. A car traveled 1,425 kilometers from El Paso, Texas to Dallas, Texas in 12.5 hours. What was the car's average speed? Well, okay, so I don't want to write that whole question, but I want to have the example in my notebook. So I'm going to say car went 1,425 kilometers in 12.5 hours. So then I say, what was the question again? What was the car's average speed? So I'm looking for speed. Speed, we can go back to our triangle and say, okay, speed is distance divided by time, or we can go right to our formula. So speed equals distance divided by time. And in this case, the distance is 1,425 kilometers divided by 12.5 hours. And I can't do that in my head, but I can pull up my calculator to pull up my calculator and say 1,425 divided by 12.5 equals 114. So 14, now that's kilometers per hour. Kilometers per hour. Okay. We don't really have a reference for that number. So if we were curious, we could go to our favorite Google cheat, right? And we might say 114 kilometers per hour. Well, maybe. And that would be about 70 miles per hour. So kilometers per hour to miles per hour. So that is a pretty normal speed for what we might see in real life. Alright, so that was an example of finding speed. If we go back to our lesson, we have another example where we're going to find distance. So in this example, a plane traveled for about 2.5 hours at a velocity of 1,200 kilometers per hour north. What is the distance it traveled? So I don't want to write that whole thing, but I'm going to say in my notebook so I have a good reference. Plane flew 2.5 hours at 1,200 kilometers per hour north. So then I know I'm looking for distance because it says what is the distance it traveled. Distance equals speed times time. So then I just plug in my numbers. I'm going to say 1,200 kilometers per hour times 2.5 hours gives me, I go to my calculator, I would find that it is 3,000 kilometers. Give me a thumbs up if this makes sense and you kind of got it. Okay. All right, we'll do one more so that we can find, we found speed, we found distance, so we can find time. Now this one is a little ridiculous, so we'll kind of talk about the ridiculousness of this one here in a second. But it says a boat is traveling a distance of 90 kilometers at a speed of 30 kilometers per second. How long will it take to reach its destination? This is like one of those, school questions. Because could a boat really go 30 kilometers per second? No, it would probably shatter, but we will still do the problem. Boat goes 90 kilometers at 30 kilometers per second, which is a ridiculous speed. How long will it take to reach its destination? Well, how long will it take is time. So time equals, if I go back to my triangle, distance divided by speed, or I could just go right to my formulas. So time equals distance divided by speed. So I'm going to get 90 kilometers divided by 30 kilometers per second. That gives me 3 seconds. So we have some kind of ridiculous speedboat there. Okay. Alright. Alright, so now you have an example of finding speed, distance, and time. Alright. The next step for us in the lesson, if we go back to that lesson, is the review questions. So we'll discuss those here in just a second.